Brian Kraft, and this is my third homework assignment for csc577. I'm going to go through the configuration file real quick, which we just added in the two weights for the Bayes classifier and the collaborative filtering recommender, and the threshold for the what's considered a like and a dislike. And so for the Bayesian classifier, we create data structures to score the probability of like and dislike for each user, and the probability of a feature given like and dislike for each user. And we're going to use those values to create the constant k later in the predict function. But we begin to loop through each user, and we initialize their like and dislikes counters to 0, and then we also make these array lists that are where each element represents a feature and the number of likes and dislikes the user had where that feature was present. So once we're in the for loop for the user, then we take we create an item iterator, and we start looping through each item, and we get the rating for the item, and if the rating is above the threshold, we increment the like or the dislike counters depending, and then we create a feature iterator for that item, and then we begin to go through each feature, and if the rating is above or below the threshold, then we're going to increment the probability of feature given like values for that user. And then at the end, we calculate the overall probability of like and dislike, and we store them in those data structures that were created above. And then we loop through each feature, and we get the probability of feature given like, and we store those in the data structures above that were created as well. And we're using the Laplacian smoothing, which has the plus ones in there. And then when we go down to the predict function, we just first initialize this running probability like dislike, which is going to be used when we're making the constant k, and we grab the probability of like and dislike from the data structures that were created in the training of the model. And so we start going through all the features in the item that were input, and we get the probability of the feature given like and dislike, and then we multiply those by probability of like and probability of dislike, and then we increment it to these running totals. And then once we've done that for all the features, we get the constant k, which is that 1 over that summation of probability of feature given like times probability of like, conversely for dislike. And so we get that constant k, and then we calculate probability of like and dislike given a feature using that k and those running probabilities that were calculated above, and then we get the log likelihood, and then we convert the log likelihood to a probability, and then we make our final prediction using the different rate calculations. To actually do the hybrid, it was pretty simplistic. We just create a Bayes recommender and user KNN recommender, and we set them both up in a setup method, and then we train them both in one train method, and then we just call the predict functions for each model, and we grab those weights we put in, and we create one final prediction, and that's what we end up returning. The only thing that had to be changed is in the user KNN, I just had to make train and predict public methods. And so if we run it real quick, we'll see it's just going to output that score of 1.